Welcome to today's webinar. I'm Robert Grotans, the Global Technical Marketing Manager at X-Rite, and I'll be moderating today's webinar. Presenting today will be Mark Gunlock, one of our solutions architects. A few things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. During the webinar, if you have questions, please use the questions function on the GoToWebinar panel. I'll be monitoring the questions, and at the end of the webinar, we will have time for a short Q&A session. Finally, this webinar will be recorded, and you'll receive a link so that you can view the webinar at your convenience. With that, I will turn it over to Mark Gunlock to kick things off.
Thank you, Robert. So let's get started. All right, so first of all, let's talk about, we need to manage color. We want to improve efficiencies in the plants in areas of job planning, ink preparation, press time, and of course, reporting for internal management and for customers. And also managing color is going to reduce waste of time and materials at the press. And of course, we can utilize our ink returns better. So let's get into what this means. So in your typical workflow, you've got many points of contact with color. There's the initial specifier. This is where they're defining exactly what they expect initially. And as they hand these specifications for their color off to the design team and the pre-media team and so on throughout the workflow, if color isn't specified in a very unambiguous method, if it's left to be subjective, as in people making their own judgment calls on what's a close match and so on, we can end up with the color drifting out for each individual job and every time you run that job. Whereas if you can tighten up and have an unambiguous standard and the tolerances are established, you can hold a much tighter match throughout that supply chain, as well as repeated over time. So our first poll question. Are you currently using digital color standards in your workflow? So if you could just provide answers in the poll there, and we can take a look at those and discuss those. All right, we're getting a lot of good feedback. Excellent. All right, so here's the kind of standards most of you are using. A lot of people using Pantone Books. There's quite a few people using customer-provided physical standards. These are the printed pieces that are sent out that the brand owner expects you to match. Fair number of ink room proofs. We got LAB targets. Actually, that's quite a substantial number there. And then a good number of digital standards. So it's quite a mix. So if we split this up, we've got a number of physical standards here. We've got digital standards, and the LAB targets can kind of fall into either of those camps. Sometimes it's simply the numbers that are provided, and sometimes it's actually digital standards. But very good information there. So let's talk about those different kinds of standards. So one of the first myths we'd like to talk about is, oops, I didn't expect that, sorry. Some people feel the physical printed sample is the best standard for matching color. If my customer gives me a physical standard, I can see what that color looks like, and I can measure this, and I can use it as a visual guide during production. But there's reasons that's not exactly the best solution. Let's take a look at that. So as mentioned in the poll there, a lot of you are using Pantone Books. Well, you have to be careful how you use those. If they're used as a visual guide, it obviously, for specification or inspiration on design, that these are quite good. But the actual books shouldn't be considered a standard. These are produced on a printing press to very tight tolerances, but as you all are probably aware, that every print run, you have variation from run to run and throughout the run. It's nature of print. So even though the Pantone books are printed to a tighter standard than most other production out there, there is still going to be some variation from book to book. So we can't use that as a standard per se. Other standards, well, the brand colors will often produce physical standards and ship them out to all their suppliers. Well, there too, this is a print piece, and each one of those is a little bit different. Now, they're managing one color, so they may be able to pull the tolerances a little tighter for that individual color they're producing. But still, it starts out a little different, and then over time, with handling, there's soiling, there's wear and tear, there's abrasions, and so on. So the colors got to change on that as well. There's also a common solution as to, well, produce a standard and then a light version and a dark version. Well, these actually aren't really any more consistent than any of those others we talked about. And in fact, they build in some subjective calls of, well, I like the lighter version better perhaps, and maybe I'll go with that, or maybe I like the darker version. Those are all within the range of acceptability. Well, we're allowing for visual subjectivity here. And then, of course, as everybody's aware of drawdowns, they're not perfectly uniform, even in the best condition. They're really intended to demonstrate how the color is going to lay down on the, and if we can achieve that color. So it's kind of test that color achievability, but it really isn't intended to be a perfect standard to be used for the rest of the workflow. So here's what happens today very commonly with using these physical standards is the brand owner may create their own standards. As we mentioned earlier, they're going to ship out to everybody, or perhaps they're going to rely on a fan deck. So they look at their own Pantone fan deck. But if they send out those standards, or they expect you to look at your version of that fan deck, there probably is a difference between those. And then you ask your ink department to match that up. You hand them that physical standard and say, can you match this? And they're going to do a good match to stay within 1 delta E typically of that standard. And here our ink department did a fine job. And oftentimes they'll create an ink drawdown that gets sent out to the press room, and the press room is expected to stay within 2 delta E of that drawdown, for example. Or maybe they may even measure at that point, but they'll work off of a drawdown for the press room. And then that's all of what we call the error stack. So the colors already from the standards already drifted out in that one production. Now let's say it's another production or even another plant. The brand owner sends that another sample out to another plant, expecting the same kind of results. And again, they stay within a tight tolerance of that original physical standard. The ink room is within 1 delta E, and then the press room is within 2 delta E of the ink room. And you can see where this is really growing in yet a different direction. And our net result between these two print runs, they may be from different suppliers, they may be from the same supplier but different locations, we have almost 6 delta E. And so when these colors show up on a shelf, one looks more like an orange red and the other is more of a magenta red. The brand owner didn't intend for that. And so their color, which is really important to them, is not maintained faithfully. Here's some real numbers from a brand owner that we worked with, and we saw exactly what I just illustrated. In this scenario, each of these converters established their press room standards in the scenario we described, and they stayed very tight to those. As you can see here, the cluster shows converter C, for example, extremely tight to their standard. B was quite tight to theirs, and A was to theirs. But the thing is that by going through their ink room and working off of different physical standards and handing off drawdowns, they ended up shooting for very different targets. And the net result here, again, from was the biggest one, B to C. Comparing those two converters, we had over 3 delta E. So what we're proposing is that if you work off of the digital standards, and there's a lot of sources for digital standards, and some are like Pantone Live, and some can be custom made. But either way, if you work off the digital standard and the increment is required to stay within 1 delta E of that, well, they should be able to get closer there. And if they're working off Pantone Live, which is a set of dependent standards that are actually designed to be achievable on different substrates, we can expect to actually get even closer matches to those standards. And then the press room is also held to match that original digital standard, not a generation from that, not a drawdown, but the actual digital standard. They can stay tighter to that. And our net result here is under 2 delta E match from production run to production run. So question number 2, our poll question number 2, do you have any customers that are specifying for color matching under multiple illuminants? So for example, D50, which is commonly used, and maybe store lighting or incandescent lighting. Excellent. Okay. Well, I was watching the numbers climb here, and actually an interesting thing was the answers for yes popped up very fast, and then the others popped up a little bit slower. And well, I kind of would guess that might be because those of you that are dealing with those customers, that's an immediate concern, and you knew right away to respond that way. So what this is about is that a lot of brand owners are starting to move towards multiple illuminant matching. This is very important for them to match in their store lighting as well as when you take it home or view it under daylight. So take a look. So myth number 2 here is, isn't lab all I need for a color specification? So can I just give LEB values to my ink guy and have them make an ink, and then I'll take those same LEB values, give them to the press room, and they can match? Well, there's lots of reasons that actually doesn't work very well. For one thing, some of the lab numbers that are distributed don't actually include all the information, like the illuminant or the illuminant observer data. These are standard ways to describe the way we view the color, which is a little beyond the scope of this session, but be aware there's a number of ways out there. In some industries, they'll use something called D65 10 degree, or they'll use D50 10 degree, or D65 2 degree, or D50 2 degree, which is actually what we use in our print industry. And you may find different ways that colors are specified that actually don't really align with what we do in the print industry, or they don't even include that information. And sometimes that's because they picked up the information and they don't have a complete information about it. Other problems that can occur with LEB data is, well, who measured it? Did they measure it correctly? Was it measured on a dark table? Was it measured on a white tile? What was the condition of the sample? Did they measure values in average across that sample, or do they measure a single value and it's a damaged area or a particularly good area? We don't know. The standard, was it actually the original color standard that was accepted by the customer, or was it some version that was created after? So, where did this data come from? So on. There's a lot of questions around LEB data, the source of it. In addition to that, as we mentioned earlier about the different illuminant conditions, the brands all want their colors to match under D50 because that's a daylight condition, that's an industry standard. But in some cases, they also want it to match under another condition like the cool white fluorescent store lighting, so that it also looks good in the store. And where this is really critical is where we're creating products that may have labels and boxes and other containers that are printed by different suppliers, or even by the same supplier but on different presses with different inks. And they want to make sure that those colors match each other on those different printing conditions under all the different lighting sources that are important to them. So they don't have them maybe match under D50, but as soon as they hit the store lighting, now the label on the bottle doesn't match the box that the bottle's in. They want to make sure they match. So a lot of brand owners are now specifying this. So you need to be able to match that. And that's not something that LAB by itself can do. So spectral data is more desirable because it can be repurposed for different lighting conditions. So here's an example of what this lighting condition issue can do for you. So in the upper right-hand corner of this window, I've got actually two patches. They match very well. There's a top half and a bottom half here. They're made with different inks. And under D50, they're matching very well. In the graphic in the bottom, we've got it plotted over on the left side in the LAB color space, and we've got on the right side a spectral curve that represents that color. If I change the lighting, the illuminant condition, and I measure this under cool white fluorescent, I can see that the LAB value is actually still pretty close here if I measure this. But when I put the cool white fluorescent on this, I get a different look, and you can see the differences between the two. Now, if you look at the bottom, you'll see the LAB plot. If I measure this with D52 degree, they're pretty close between the top and bottom there, and the spectral curves, though, are quite different. This can lead to a real problem of those matching components to my packaging. They'll have the kind of look we see above there. So, poll question number 3. How often are you required to perform on-press approvals? This is where you're going to have your customer often standing in the press room, watching for these approvals and signing off OK. Okay, so those of you who said never, I bet you feel very glad you don't have to deal with that. But there's a number of you that at least half of you are going to have, sometimes you have to deal with it, and on others, you're dealing with it most of the time. So there's a lot of users that are having this occur fairly frequently. The brand owners, by the way, actually typically don't want to pay for this either. This is an expensive thing to do to send people out. So part of the reason they do that is because they're not sure about the repeatability. Can they really trust that you can hit their colors they're looking for? And in some cases, usually they come out on the first run. In some cases, they come out for subsequent runs because they're seeing problems and they want to see how you're hitting those colors. So myth number 3 is for process control, as long as I save a retain sheet from the end of the run, and next time I run and I match that one, I'll have continuity. I'll have my color is going to maintain over time. But the problem here is that we get a drift in those colors. So here's kind of the progress. We've got, some operators going to say, hey, we save a physical sample, the press measurement, or the press measurement says aims for the next run. So they measure their last sheet, or they actually just hold a sheet and they use that as a guide for starting their next run. There's some operators that and shops that are actually going to continue to run standards, but they're not necessarily concerned with any kind of previous run. And there's probably the very best way to go is to print the digital standards, but also record the data and review it later. And that way you can see trends of what's happening. But as you move across, from this first example to the last one, there's tools that can help you get there. So starting with spot color specifications. So as many of you are aware of, you may have digital data, or you're going to measure to create your digital data. The customer ideally is going to provide you with digital targets, and then they're going to give you a tolerance. So what do they expect you to match to? Is it 2 delta E? Is it 2.5 delta E? And actually, I made a point here to make sure this is delta E 2000. This is where most of the tolerancing is moving now. In the past, you may have seen CMC as the method, but they're moving to 2000. That's pretty much the whole industry is moving in that direction. So if your customers aren't there now, be aware they're probably going to move there to using the delta E 2000 method for tolerancing. Now, if I'm just looking at my spot colors, I need to have really good information to know if I'm hitting that. And a tool like ColorSir's QA tools, here's an example screen, what we see in there. And you can see we've got the LAB plot for this color that shows me the range in the ellipse here that shows what colors would be considered intolerance. And I can see the current measurement I've got is out of tolerance here. It's a little too on the red side. I can see the spectral curves here. And again, these curves match pretty close. So I have a good chance of making some adjustments to get a better match. If I looked at these curves and saw a lot of crossovers like my previous example, then I would know that maybe I've got an issue with a metamerism. These colors may match under D50, but not under my store lighting. I've got a list over here that show all of the measurements that I've taken, and they're all date and time stamped so that I can see how I've performed in the past. And in fact, I can pull up another window that has what we call a scatter plot that shows how those measurements have behaved in the past. So I can see in the scatter plot that, well, my current measurement, that's this star right here, and all these other measurements, this is typically where I print relative to that standard. So typically I'm intolerant and I'm slightly on the red side. Now, this can be very important to you because let's say today you're measuring over here on the opposite side, the green side of this color. Well, this delta E ellipse represents a 2 delta E from the standard. However, keep in mind, if I'm printing over here today and then over here next week, that's a bigger than 2 delta E from run to run. Each time I may be 2 delta E from the standard, but from run to run, I'm pushing almost 4 delta E. So it's important not only to be within that tolerance ellipse, but being consistent in the same area. Another important tool that's included with QA tools is the ability, again, because we've got spectral data, we can actually see what our current measurement is. We can see this current measurement we have here is 2.07 delta E, and in this scenario, that's out of our tolerance range, okay? But we get feedback in the software that says if we lower the ink strength, or we could change this to density, if we lower the density on our press, we can actually get down to as little as a 1.67 delta E. That's actionable data that the operator can work off of, and that's also illustrated in this graph here. On the left side, we see our delta E's here, and our tolerance is at 2. Across the bottom, in this scenario, we show ink strength, although this could be ink density. We can switch that. And the line here, the black line here, represents the way that our delta E's are going to drop, or our color is going to get better as we increase our ink strength here to a level here, which is the lowest delta E, or our best match, which is identified by the green line here. And this says that we could get to as little as a 1.67 delta E. Now, as we go off to the right here, following the black line, we'll see a black dotted line, which represents our current measurement at 2.07 delta E, and the ink strength is quite a bit higher there. So it's saying if we bring down our ink strength, so we add a little extender, or we lower our density, we should be able to bring that down to 1.67. So this is very useful for the operator to know if they can make a change on press, so if ink strength or density, to get that match, or if they can't get a good match, in which case this black line here that goes this little curved line, if it doesn't go below that red tolerance line there, then it means that we can't get there, and we need to talk to our ink technician to help improve the color. So we get the right person to help us look at the color. So the QA tools is all about just simply pulling up a color and matching that color. It doesn't require any work other than to create standards and store them in this database. It also does provide some ways of sorting colors. So if you want to sort them by customer, so for each of your customers, you'd have a collection of colors, or even by a project, which is for different products that I produce or families of products that I produce. I could put all those colors into a project for that, just to help the press operator to select colors faster. So QA Tools is a great entry-level tool to start measuring to these provided digital standards, to get that good pass-fail quick response, to record the data to look at in the future, and to see how you're doing over time matching that color. Here's more information about that best match. It also provides graphic showing the standard. You can see here in the center, this is what we're shooting for. The left side shows what we actually measured, and the right side says if we adjust our density, this is the best match we're going to get. So in these examples, you can see, again, actionable information for the press operator. The top one shows, hey, this is a great match. You're not going to do much better. Just keep running. This is terrific. The second example shows, yes, you got a match that's under 2 delta E, but you're hanging real close to the edge there. It's a little dangerous out there. So even though you are passing, you may want to consider checking with your ink tech to see if you can get a better match. Or the bottom example shows that it's out of tolerance by quite a bit, and as a press operator, there's nothing you can do to make this ink work. You're not going to be able to adjust with the strength or the density, so you definitely want to get your ink technician in there quickly to resolve this issue. So again, kind of important here is that you have the right person addressing the problem with the right tools. Now, the previous example I just showed you was working with just matching single spot colors, which is commonly done. But be aware there's also a lot of customers that are looking at matching a whole print quality specification, which describes standards and tolerances around your substrate, your paper, your board, your film, your CMYK solids, perhaps your overprints, sometimes your TVI or gray balance, and of course your spot colors will also be included in that. So they want to look at a lot of different print metrics. They have a lot of different tolerances around these, and you don't want to have a press operator trying to remember what these different things are. So it's really good to put it into the software. So ColorSir has a feature called Pressroom Tools, where you collect all of these different metrics and assign to them all the different tolerances that you expect for them. And then the operator can measure these in an automated fashion. So in this example, we can see we've got primaries. We can also measure dot gain and spot colors. You can see across the bottom here, there's something we call a media strip, or sometimes called a color bar or a control bar. These can be formatted in a number of different ways, whether you're doing offset printing or if you're doing flexo printing or gravure. These patches may be in a strip, in which case we can actually use the exact to measure those with a scanning function. We can scan straight through all these patches and capture the data quickly. Or the patches may be scattered in different areas on the output. Sometimes it has to be put into different blocks around the repeats of labels and such. And so you may have to measure these manually in a spot-by-spot method, but the software will, in a wizard-like method, walk you through measuring each of those patches. Either way, you collect all the data into the software, where you can then do the same thing like the best match I described earlier. Once you've measured all the data, the idea is we want to get the operator to look at the problem areas quickly. So the software works on a red light, green light method here, where you've got the primaries, for example, and the dot gain and spot colors as different areas. And you can see that the primaries look good, so we don't need to look at those, but the dot gain maybe, or the spot colors need attention. So they'll have a red X in there. So the operator would drill into those areas. And once they drill into an area, they'll be able to see all the colors are in that area, and they'll see green, which is good, and red that's failing. And then, so we need to focus in on the areas that are failing to fix those. And here too is we can have something like this graph, like best match, showing, well, we've got a failure because we're 2.07 delta E on this color. And if we, and it's again the scenario, if we cut our ink strength or if we lower our density, we can bring that down to a 1.67 in this example. So help them get to where the problems are fast. Don't spend time focusing on stuff that's already passing. Focus your attention on things that are failing, go to the red, and then drill down to the details and find numbers or best match, other tools in here that help the operator to take action to fix those color problems. The other thing that is good about shooting to digital standards and collecting this data, everything I just showed you is a run by run kind of thing. But as you develop a more complete color management workflow for your whole process, your whole press room, you can start collecting this data and storing it in a scorecard system where you can then look at trends of jobs over time. You can analyze and improve your process. You can look to see that same job over time, how well have you produced that job? So we can look at scorecards for that. And then on the scorecard, you can look, as you can see here, we've got a graph of jobs over a month period. Now, this is a little jaggy. This is made with sample data. So this isn't really reflective of what most people are looking at. I'm going to show you what most people see here in a moment. But you can look at this, and then at each of these days, you could go in and say, well, we had problems on this day. You click on these days, and you can pull up the jobs that ran that day. And then you can look at jobs that were good or bad on that day. And this example here, I can see that my substrate color was a failure on this job. And you can drill down to figure out exactly what went wrong with that job on that day. You can drill down to look at a color. This particular spot color was run over time, and we can see how it performed over time. And on each one of these dates that we have, we could click on this node here and pull up the jobs that were running poorly or well on those days. We can also look at substrate. Now, that's a critical thing that a lot of people are overlooking, but we can see that this substrate was pretty consistent over time, but we had a few times where it was failing. And you could go back and take a look at those and see, well, what was the issue on that day? This is all useful data for improving your process over time, okay? Here is actual data we've collected from a customer who was just starting to implement this workflow. And we can see what they were doing in their first jobs they were measuring. They had a lot of variation, and some pass and some fail. But as they implemented this process, as they started to look at their key problems and resolve these, we saw that their scores were getting better and better and being much more stable. So this is what you can do with data, and then going back and addressing the issues. So that is the content that I had for everybody today. I'd like to open up for questions. If anybody has any questions, I'd love to answer them.
Yep, if you haven't submitted a question at this point, you can go ahead and submit it now, and I will read them off to Mark to answer. So it looks like we did get a question already. The first question was, can we just get a copy of the presentation? We don't give a copy of the presentation, but you will receive a recording of this webinar to your email within a day or two after this presentation is over.
Any other thoughts or questions?
Yeah, okay, now we have some coming in, it looks like. So does the ColorSir software export curve sets?
Okay. So the ColorSir software, there is a tool in there for doing press calibration for spot colors, but it's not intended for doing anything like your gray balance curves, your TVI curves for spot colors for most scenarios. It's not going to be it's not intended as a tool, for example, to comply with G7. It will measure all the G7 metrics to help you know if you hit the numbers, but doesn't have a calibration tool for G7 metrics.
Okay. Can you make a color proof directly from ColorSir on an Epson printer?
ColorSir actually doesn't print any of the jobs, but we can use ColorSir for measuring those proofs off your Epson printer, so that you can tell if the proof itself is aligning with the targets you're shooting for. In fact, the settings in ColorSir can be adjusted to be sometimes they'll want them to be like to a tighter tolerance than the press. So they may actually set their proofer to be say half or somewhere in between half and full tolerance that we run on the press. But it's just meant to validate the proof and validate the press run. It doesn't actually contain the jobs for proofing purposes.
This question might be a little general, but someone would like you to go over setting tolerances.
Yeah, so there's a couple things. There's establishing the tolerances, which would be, we need to figure out what our production tolerances would be, and that's going to be, first of all, it's an agreement between the print converter and the customer as to what that would be. Now, some of the brand owners are going to establish their tolerances and provide you with those numbers, and then others will work with you to determine what they should be. But in either case, it really should be realistic numbers based on real production variability. So if I'm printing on a, say, an offset press with very good control, perhaps I could, establish 2 delta E as my tolerance for my spot colors. But if I'm printing on a material that varies quite a bit, or I'm printing on a big web press that there's a lot of variation on production, then maybe I need to expand that tolerance to more like 2.5, or on some substrates even 3 delta E. Now, once those are established as what the tolerances would be, the software actually has areas where you can key in those tolerances, and every metric that we described in there, whether it's CMYK or spot colors or your RGB overprint, there's a separate area where you can enter those tolerances, because each of those types of print would have different tolerances. But we can put those into the software directly. I can't show you at this time. If you're very interested in seeing more details on how to work with ColorSir, I'd recommend contact us or contact your X-Rite salesperson directly, and we can schedule a web-based demo of the product for you to show you how you'd set those up in greater detail.
Is CXF a good method for sharing color standards?
Absolutely, yeah. So that's an excellent question. So there's there were other legacy formats for saving digital colors. So some of you may be familiar with our older software, Color Master, which we're phasing out. It's actually discontinued, and its standard method was what we call an MIF file, which was fine in its time, but it was proprietary. It was only used for that application. CXF has been, Great Tag Macbeth and then later X-Rite owns CXF originally, or developed it rather, but we made it available for the industry as a standard. So it's now actually part of an ISO standard for sharing color data. And in fact, CXF can store a lot of color data. It's kind of beyond the scope of this session, but it can store a lot of different kinds of color data. And that's a great way to share. So you can create a set of colors you want to use for a project or a brand campaign or whatnot, and you can distribute that to all the suppliers. The Pantone libraries are actually all based on CXF, but it's all being distributed now in what we call Pantone Live. Pantone Live is a cloud-based solution where we store, again, CXF of the Pantone digital standards, as well as what we now call the masters, which represent all the books that we print, as well as the Pantone dependent libraries, which are collections of Pantone colors that are optimized really around different kinds of print conditions. So there's white film, there's folding carton, there's label paper, there's offset, there's flexo, there's gravure, a number of different print conditions, and where we've actually gone through and recognized that the gamut or capability of color for each of these different print conditions is a little bit different, and we've modified these standards to provide users with achievable targets under these different print conditions, rather than having them use targets that are beyond what they can hit there. So these are just all different ways that CXF can be used. So you can use them for your own custom colors, and you distribute the files yourself. It can be emailed or put up on a server, or you can access Pantone Live, which is all based on CXF as well.
This question is kind of along the same lines. So does that mean, can you import current customer standards from other pieces of software into QA tools?
Yeah, in fact, for some users, they may already have their libraries created in, say, ColorMaster or IQC or other QC applications. And that is the way that we would expect that you would migrate your colors over from some other applications, or to share them from, say, a brand owner to a converter and that kind of thing. So CXF it's a color exchange format. It's intended for transferring or exchanging color data. That's perfect.
In QA tools, is there a frequency of measurement that you recommend, or what does that process look like?
Okay. Yeah, so with the press room tools that I showed you, that one is very clearly defined. Usually when a brand owner requires you to use that kind of tool, it's usually like on a flexo or gravure, it might be the end of every roll. So that's kind of frequency. Every roll gets a measurement. If you're doing offset or sheet kind of work, they may give you a certain frequency in that scenario, and the brand owners vary on that, what frequency that would be. With the QA tools, that one's usually when people are doing QA tools, it's all just for internal measurements. It's not driven by a brand owner initiative of any sort. And there too, it's kind of like whatever your house rules might be. You just want to make sure you're capturing a frequency that that would help capture variations in the press. So you may, for your own purposes, you may want to do a higher frequency starting out as you start measuring digitally. And if you start seeing that, well, our colors aren't changing that frequently, it's staying pretty stable, then you may be able to extend the frequency out a little bit further. But at a bare minimum, if you're doing roll-to-roll kind of work, you'd need to do every roll. If you're doing sheet work, then it's really just a matter of how often you feel like pulling something and how often you believe that the press would drift. So you can capture that drift and correct for it before it gets too far out.
We got a lot of good questions.
Good.
Looks like we have time for a couple more. Can a process color be reformulated by the ink provider?
That's a good question. I would say typically not. Generally, people want to run with what they call monopigmented inks as their CMYK inks. Now, that said, if you go to your ink provider, they may have another, another primary ink that would work better for you. I've been to some sites where they were using, say, a less expensive ink, and the hue angles were not within tolerance of the standards they're trying to match. And when they went back to their ink provider, they said, well, that's the ink. However, we do have another ink. It costs a little bit more, but the hue angle is better. And then you're able to actually hit maybe print standards better. Again, beyond the scope of this discussion, I mean, sometimes people on Flexo, whether they're printing on film or board, they may be targeting some of the industry standards like SWAP or Crackle or others, and where you'd have to make sure you pick an ink set that helps you get there. Some ink sets just won't align, and typically it's a bad idea to try to tint those inks or tone those inks to get a match.
Perfect. Okay. Looks like that was all the questions we've received. There were a few other questions. We'll have a salesperson contact you if you were asking about pricing. So with that, you'll receive an email to a link of the recording after this webinar ends, as well as additional resources. I'd just like to say thanks everyone for joining today.
Yes, thank you all.